You grew up in the upper Midwest, right?
Yeah.
Okay, so you're probably familiar with this sort of science demonstration that you do on those bitter cold winter days.
Where you stand the egg up.
No, not that one. It's a different one, but same concept, I guess. But those bitter cold winter days where it's like 5 or 10 below zero.
Yeah.
You're a kid. You're getting ready for school, dreading going out to the bus stop, but there's this, and I'm telling you this, and I'm sure you've already experienced it. But
yeah,
for the other
frozen
listeners,
hair.
Yeah, right.
Yeah.
But yeah, it's bitter cold. Like you're thinking they should have canceled school.
Yeah.
But it gives you the opportunity to do the science demonstration / kind of prank. But so you get 2 mugs of water and put them in the microwave.
Oh yeah, I know where this is going.
Yeah, heat it up for like 10 minutes, like get the water up to about 400 degrees, so it's just boiling and super, super hot. And then you do this right before you head out the door to go to the bus stop.
Yeah.
Your friend's waiting at the stop. You're like, hey, my dad made us a couple mugs of hot chocolate, as we're waiting for the bus. And, you walk over, you said, be really careful. It's super hot. You might have to let it cool down for a little bit. And as you approach your friend to hand them, one of the mugs of hot chocolate, you pretend like you trip.
Yeah.
And you throw both mugs of the boiling hot water in their face.
Yeah.
And they just like freak out. But since it's so cold out,
Yeah.
the water freezes as it comes out of the mug, and
Yeah.
it's just like throwing a cup of snow in their face.
Yeah,
It basically
it's
turns
incredible.
to frost. Yeah. So it's that concept, like I said,
It's like when the not to interrupt you, but it's like when the Harlem Globetrotters throw that bucket of whatever marbles or whatever on people. You know what I mean?
Exactly.
They think it's water, but it just turns out it's like rocks or something.
Yeah. So this was boiling hot water, but when it's that cold out, the science behind it is hot.
Yeah.
Basically, hot water freezes faster than cold water.
Right. Yeah.
So you get super hot water and a super cold temperature. It comes out of the mug. Basically, it turns into snow. And you're throwing a cup of
you
snow.
tell people that they don't believe you, though.
Yeah. But you got to. Yep. But you and I growing up in the Midwest, we've seen this happen. Enough times where you know it's coming.
If you see somebody walking down the street with a couple of cups in their hand.
Yeah, I mean the same idea probably down south is like, hey, you want some peanuts, and you open it up and that thing flies out. Once that's happened to you a couple times,
right?
You know it's coming. The same thing with the steaming mug. So anyway, it's a fun demonstration, to show you how science works and everything. But there's a practical application of it. But unlike any, or like any shortcut like this, there's kind of unintended consequences. Yeah. So, have you ever worked in a restaurant?
Yeah.
Okay, I haven't, but you don't really need to have worked in a restaurant to sort of understand this.
Okay.
But so, say it's a Monday night or something like that. It's traditionally a super slow night. And, you do your prep work based on kind of your expectations of how much business you're going to have.
There's a French, was it mise en scène? What do they call that?
Oh, I don't,
maybe I'm not to interrupt you.
I think it's
like that.
Just-in-time inventory, I think is the...
A la carte. I always forget what the difference between a la carte and a la mode is.
I'm just thinking like a pizza restaurant or something.
Yeah.
Not anything French, I guess. But so you do your prep work, you cut up like the onions and mushrooms and all that stuff, and you make enough ice to, just to get you through the night, So for some reason, you expect Monday to be slow, but you just get swamped, and power goes out or something. Everybody's going out to eat, or it's whatever.
Maybe Monday's fish fry night where you
yeah, and you didn't prep for that, so you run out of ice, and you got just customers lining up and stuff. So what a lot of restaurants will do is like, we're low on ice, we need ice fast. They'll start making ice with warm water because it'll freeze faster.
Yeah.
Start filling the cube trays with, just hot water out of the tap or whatever, and they'll freeze in, 20 minutes, half hour or something like that. But then it stays busy, and then, you just all of a sudden, like, you need more and more ice, and you're to the point where, you get to the point, it's like a vicious cycle or whatever.
It's like the law of returning averages or whatever they call it. What is that called?
Yeah, regression to the mean.
Yeah, something like that.
So what happens is that ice you're making with the warm water actually melts faster. So, you fill up a cup with ice, and then you pour this pop in or whatever, and like you've probably seen this before.
Yeah.
You'll all of a sudden like 3/4 of the ice disappears.
Yeah.
And that's because the melting point.
Is that what causes, like, sometimes when I'm pouring pop into a cup of ice, it'll fizz up and go over the top? Is that because maybe it was because the ice cubes were hot water ice cubes?
Or maybe cold water ice cubes. I'm not sure.
Yeah.
It could be,
good point.
So yeah, the issue is, so this ice made with hot water melts faster, so you got to make more ice, and you're getting to the point where you know, this restaurant will have like 5-gallon, you know, pots of water boiling on the stove that they're just so constantly filling ice cube trays, you know, and you know, I guess sort of that unintended consequence. It's like, oh, we can get this ice out faster, but this ice melts so fast that you actually get to the point where it will freeze faster, but it will actually melt
quicker.
It will melt in the freezer, because I think the science behind this is, you know, it freezes faster because hot and water molecules are farther apart. They're more active, so there's more room for the cold air to get in between and freeze it. So this ice is less dense than normal ice because the water is expanded, and it freezes faster because the cold air can get in there. But then you have this ice that has more gaps in between the molecules, so now the warmth gets in there faster. So it actually thaws out at a lower temperature than regular ice because you've created this ice that's sort of...
It's sort of like how water under intense pressure can be colder than the temperature of ice.
Exactly. Yep. Yeah. So it's sort of the flip side of that. So you make this ice with the boiling water. You can make cubes in 5 minutes, but those cubes will actually start thawing in the freezer before you use them. So it freezes faster, but it melts faster, I guess, is the way when it comes down to it. Yeah.
Talking about ice trays, you know why? Did you know? You ever notice that all ice trays are rectangular?
I hadn't noticed it, but now that you mention it,
you know why that is?
I don't.
You can't. But the laws of physics, you cannot crack a square ice tray.
Oh,
think about it.
Like sort of it's so you can't like twist it.
You can't twist it. It doesn't twist because the same sides are all the same length.
Okay, yeah.
You know what I mean? You got nothing to. There's no smaller part to grab onto and twist.
Yep, it's all every part of the square is equidistant from the other part. There's nothing.
Yeah, that's why you never see one that has equal sides.
Yep. That I assumed it was a.
You know, it's interesting though that. You could have a tray that had equal sides but still worked as a tray if it was like a parallelogram.
Oh, yeah.
You know what I mean? Those have equal. You can have an equal-sided parallelogram, right?
It's the 90-degree
you can take the corners of the parallelogram and yeah.
I always assumed it was just like that rectangle is the maximum efficient for like storage wise, like that's what I always thought is like it fits in the freezer and it's like the most.
Let me ask you this: you ever notice that in any freezer that has a little box for the ice? Do you notice there's room for two of them there?
Yep.
Maybe the reason that there's why not just make? I mean, it's big enough to hold a square one, right? So. Yeah,
but you know. Like talking about efficiency, a freezer and a fridge are actually a rectangle too.
That's true. That's a good point. Maybe there's something to that.
The depth, you make it long enough.
You know what else is too is bread.
Yep.
Interesting.
Yep. A lot of people.
And eggs.
Yep. Everybody will try to say that a sphere is the best way to store something, but actually, a rectangle, not a square, but a rectangle is the ultimate efficient storage container.
Yeah. 2 questions. Number 1, can you look at like 2 ice cubes sitting on a table? Can you tell which one was made with the warmest water, the hottest water?
Not without destroying it, I guess.
Okay.
I mean, you could, I guess, under a microscope or something, you could compare the two.
Because you could see how far the atoms are how apart they are.
Yeah, but otherwise you just do the standard test of you pour, room temperature water on it, and the one that was made with hotter water will melt before the other one.
You know how they say that the best way to calibrate, and sorry to get off on, but this is interesting information. The best way to calibrate what's a temperature taker called that you dip in things? You put it in like a turkey,
Oh, but brace.
A thermometer.
Yeah.
Thermometer.
Okay. Yep. Yep.
You know how they say the best way to calibrate those is to take a glass of water, fill it with ice, and stick it in there. And if it's 32, that means it's completely accurate.
Oh yeah.
That's bullshit.
Oh yeah. I guess it would be because it depends on that. Assumes you would have to have made that ice at room temperature
Right.
water. Yep.
I think that's and I think this is actually it's. I've always known it was bullshit, but your thing about the ice, I think that lends even more science to the fact that that's bullshit.
Yeah.
It's sort of, what do they call that in trigonometry? It's a
Proof.
yeah.
Yeah. Is it? Yeah.
Yeah, wow. Yeah, that's exactly what I was thinking
Yep.
of. Yep.
So, yeah, and I guess that's the all these, water freezes at 32 degrees, but there's another question before that, like what temperature was the water before it was frozen?
Yeah.
Like all these, and
The
water
history-
boils at 100 degrees, but what's the pressure outside and how warm was the water
Right.
before you started boiling it and all that.
Yeah.
So there's always these qualifiers, and people take these mental shortcuts. But now you see how they backfire. Like this, this restaurant worker's like, oh, we're running low on ice, so let's make it with hot water.
Right.
The unintended consequences are you get in this cycle where it's sort of like drinking salt water. Like, oh, I'm
Yeah.
thirsty. I need to drink, the only thing available is I'm stuck in the middle of the sea. The only thing available is the salt water. I guess I'll drink that.
Yeah.
But then you're like, oh, it makes me more thirsty. So you just keep drinking more and more salt water and you just constantly, you die of thirst because you get more thirsty the more you drink. And yeah,
I feel like if I was stuck, and I maybe everybody thinks this, but I feel like if I was stuck on a boat in the middle of the ocean, I feel like I could figure out a way to drink that salt water and not, die from it.
there's got to be a way.
I think if you just I think if you sip it, I think people drink it too fast. I think that's the problem. I don't even know if it's so much the salt as it is. People just get so fucking thirsty when they're on a, laying in a lifeboat.
Yep. No
They just
self-control.
can't, no self-control.
Yep. And then maybe a better analogy is, do you ever use Armor All on your dashboard and stuff?
No.
You shouldn't, because it actually will dry your dash out. So what that Armor All does is pulls moisture out of the dash to make it look like it's like your dash is wet, right? Mm-hmm. So when you apply Armor All, you're just sucking whatever moisture was in the dash from the factory. So that comes out, it evaporates, and then it looks dry again.
Yeah.
You apply more, it extracts more moisture out to the point where it will be so dry and brittle that when you spray the Armor All on it, it will actually, the Armor All soaks in and then immediately evaporates out. You could not apply enough Armor All on your dash to make it shine again.
Wow.
And that's the same thing with the ice, is like if you make it with progressively
Yeah,
hotter and
yeah.
hotter water, it freezes and melts before, you're pulling the trays out of the freezer and it melts before you get it in the glass. So the lesson is, just make more ice than you think you'll need.
Yeah, absolutely.